so I wouldn't have to bring it, every single time. There we go. Okay, so it is working. The mic, last time I checked, was out of battery, and no one has replaced it yet. Yeah, these two are already used up, and this one doesn't use the same type of battery, so there's no mic today. I think we'll still be okay because I'm staying close enough to the mic. Okay, so what we'll do today is we'll take a look at the past exams. Okay, I haven't taught this class since 2014, which is about 2 years. But for the most part, we haven't really changed a whole lot of stuff here. So what I'll do is I'm going to go over the instructions for the test. This is a PDF which doesn't really lend itself to be displayed on a projector because it doesn't wrap around, correctly. But for the most part, we can still use it. The basic instruction hasn't really changed, back from those days. It's for the most part an open book, open notes type of exam. If you want to bring, you can bring anything that is either printed or handwritten prior to the test. Okay, which implies that you cannot write something and then pass it on to the next person just because it's written. So you cannot do anything, do any communication during the test. Okay, that's the bottom line. But other than that, you can take your, you can bring all the homework assignments. Okay, all the solutions to all the homework assignments. That's fine. All the notes you can find on Moodle. That's fine. All the stuff that you can find on Google. Okay, you just have to do it prior to the exam. Yes. Question?
Would our homework be graded by then, so you can?
I'm starting to grade some of the last ones, but I always give you the solution.
Oh, that's right. That's right.
Okay, so you are allowed to bring my solution as well as your own homework. Print it out and bring it with you. Okay. You can also bring pictures. Okay, if you can bring scratch paper if you want to draw a picture of an algorithm before you trace it. That's fine with me. It's just that the picture itself is not going to worth any points. Okay, so I need to look at the trace to give you points. Yeah, that's about it. Are there any questions about what is allowed? Printed or handwritten material prior to the test. Okay, prepared prior to the test. You can work together. You guys can study together and come up with material that you can bring to the class for the exam if you want to. Okay, that doesn't bother me at all. You can bring calculators. Scientific calculators are okay. Simple calculators are okay. Cell phones are not. If you don't have a normal calculator because you regularly use your cell phone as a calculator, the Dollar Tree has calculators for $1. So I would highly recommend getting one of those. They even have scientific calculators for $1, but it's not all the time. Okay, but at the beginning of the school year, they do have scientific calculators for $1, and I buy those for my kids. Just in case they lose one at school, it's like, okay, $1. It's not good that they lose it, but it's not hurting a whole lot either. If you want to bring a dictionary, that's fine with me. But it has to be a paper type of dictionary because I don't think anyone has a Franklin electronic dictionary these days anymore.
Might have one somewhere.
I think those were put into the same drawer as the Game Boys.
One of those
the questions, you might want to consider answering the questions out of order. Just make sure that you spot and locate the easiest questions first. Okay, that's usually a good strategy for taking tests. What is not allowed would be any electronic devices that is not explicitly allowed. So to most people, that would be cell phones, tablets, laptop computers, Microsoft Surface computers because they're kind of a tablet but also a laptop computer. So anything that is electronic like that, we cannot use those during class. Okay, during the midterm. Live communication is also not allowed during the test. The only person you can interact with is me. So you can ask me for clarification. Okay, I can tell you, okay, I can only give you clarifications, which means I can clarify what a question is asking, but I cannot answer questions like, oh, I just forgot what this mod operator means, okay, MOD. Can you tell me what it means? I cannot give you that, okay, because it is open book and open notes. It is in the notes, so you have to remember to study and bring the notes with you. If you, in case you think I might forget about certain things, details and stuff like that, you'll bring the notes with you. That's about it. The tracing standard is going to be the same as your homework assignment, okay? So there's consistency there. For the pre and post condition derivation stuff, you have to explain why you choose one rule or the other, okay? And you have to explain how the post condition of one statement connects to the precondition of the other of another statement. So you kind of have to explain, step by step, how you derive the answer. Okay, so we'll do some of those questions today, okay, as a demonstration. All right. Are there any questions about the first part here? Okay, if there are no questions,
We're just writing the answers on the binder paper? Sorry.
On the exam paper itself.
Okay,
So I'll
okay.
give you a lot of space. If you
Okay.
need extra paper, you might want to bring your own paper. And if you are going to bring extra paper to the test, I recommend the grid type
Graph
because
paper.
they are all aligned vertically and horizontally. Okay? But if you just want to use your plain white paper, as long as it is clear to me, which row, where the rows are and where the columns are, it will still be okay. But grid paper is just a whole lot easier to deal with. All right, so these are actual questions asked in that particular year. So we'll go, we'll start with these. Code tracing. Turn in the trace of the following code. Assume x equals to 300 and y equals 298 before the algorithm starts. So those would be the precondition. If you think the code results in the execution of an infinite loop, indicate so and briefly explain why. Okay? All right. So we'll take a look at this code here and we'll trace it. So you're going to have to trace it using a piece of paper, which means you have to use the shorthand version and not to fill in the value of every single cell because that would take a lot of time. Since I'm doing it on the computer, I'm going to use LibreOffice to do it. Okay, I'm going to start a new document just for this. There we go. So even though you're doing it on a piece of paper manually, you still have to follow all the same formatting rules. So you start with a line number. You start with, oops, actually I take it back, comments and then line number. So these two are fairly typical. One thing that you might consider doing, okay, is not required, just something you might want to consider, because I'm not going to do it for you because it's going to cost me toner and paper, is to pre-format something like this on blank paper. So when you need to do a trace, you just take out your blank paper for tracing that already has the basic rows lined and some of the columns already drawn. So that makes that will save you time, and it will also help remind you, what you need to do when you do your traces. So just a little recommendation. Okay, the line number doesn't need to be too wide because it only needs to accommodate a single line number.
What's the maximum amount of variables? What's the maximum amount of variables?
Maybe 4. Yep. So in this case, we only have 2 because we only have x and y as variables. So x picks up one column, y picks up another column, and we'll make these a little narrower. There's no need to take up that much space. But in this case, we do have a precondition because the precondition is x equals to 300 and y equals to 298. So x starts with a value of 300, y starts with a value of 298. That's our precondition. So normally we put a question mark because I don't tell you that specific variables start with a particular value. But in this case, I do, so you have to use those as the precondition of the algorithm. Any questions? Okay, if there are no questions, we'll actually work with the code here. We start with line 1. Okay, so line 1 is the condition part of a conditional statement. And we have to trace it, okay? So the beginning of an if statement, the beginning of a while statement, and also the end of a repeat until statement, those will need to be traced. In this case, this is line 1. It is asking the question about x is greater than y. So it's either true or false. Is x greater than y? It is, okay, so it is true. So that means where do we go? We go into the then portion of a conditional statement, which is between the word then and the word and if or else. Okay, sometimes we have an else, but this time we don't. We go to line 2. Line 2, we also have to trace because it is the beginning of a while loop. It has a condition to evaluate. So every time a line has a condition to evaluate, you have to trace it. You have to indicate whether the condition is true or not, because otherwise I cannot tell why you get to the next line. Okay, so we go to, this time we check whether y is less than x or not. The answer is true because it's really the same question as the one before. When that condition is true, we go to line 3 because we get to the body of the loop. The body of the loop is just adding 1 to y. Y goes from 298 to 299. And then where do we go? Back to line 2. Okay, so every time you're at the end of the body of a loop, you have to go back to the beginning in the pre-checking loop. So we go back to line 2, we check the condition again. Y is less than x is still true. We go back to line 3, we add another one to y. Y becomes 300. Then we go back to line 2. The condition is not true anymore because now they are the same. So I just want to use this opportunity to point out that a few people made a mistake. You know, if 5 is less than 5 is false. Exactly. Okay, so just make sure that you remember that. Okay, 5 is less than 5 is false. So in this case, 300 is less than 300 is false. And then where do we go? We go to line 5 because line 5 is at the same level as the pre-checking loop. So when we are done with the pre-checking loop, we have to continue execution on line 5. Okay. Line 5 doesn't do a whole lot of interesting stuff. Just put a 0 into x. Okay, 0 into x. And where do we go next? Post. Exactly. We do not trace line 4 or line 6 because those lines only help to indicate where is the end of a construct, but when we run the code, they don't do a single thing. So that's it. That's the end of this trace. Are there any questions about number 1? Question number 1. Okay. No questions? Yes?
So this is a previous test from some years back. Are we expecting the same sort of thing? Or is it going to be similar to
If I can, I would choose not to answer that question, because when I do answer that question, I get people coming back to me and say, but you said it's going to be about the same, and then they all say that no, it's not the same. So it's my objective that I want to give you an exposure of what type of question that I will ask. You will be sure that there will be traces that you have to do. It can involve everything that we have talked about: conditional statements, pre-checking loops, post-checking loops. It will involve assignment statements. It will involve, the operators that we have talked about in this class. But in what way am I going to put everything together? I have no idea yet. Yep. Mm-hmm.
If we were going to pre-format some trace grids, can you say approximately how many we should bring? Less than 10, more than 10?
There'll be only about 5 questions or so. But if you're writing on one and you realize you make a mistake early on and you want to start from scratch, that will take up 1 page. So I would bring maybe 6 or 7 pages. They will be useful for the rest of this semester too. So if you print extra ones, you can just save it for the next test. Yep. There we go. Any other questions about number 1? No questions about number 1? All right, let's move on to number 2. Okay, number 2 is asking, step by step with explanations, derive pre-2, pre-4, post-2, post-4, and post-5 of the following algorithm. Assume the following. Assume pre-1 has some known facts about the variables. Okay. Have we done something like this before? Okay, this one is just going forward, which means it's not going backwards. Going backwards is a little bit iffier sometimes, but not by much. So for this one, I'm going to use my mouse pad to do it. It's just a plain text editor because that's all I need. All right. So we'll start with pre-2. Okay. Now, when I say step by step, I mean step by step. So the question is, what is pre-2? You have to give me something that is based on the structure of the code. Okay. So based on the structure of the code, what has to be true when we are about to execute line 2? Whatever is in pre-1 has to be true. Not post-1, there's no such thing as post-1 in a conditional statement. But we know that whatever is in pre-1 still has to be true. Why? Because nothing has changed. Exactly. Nothing has changed from the time before we get into this conditional statement to the time when we are about to execute line 2. So whatever is in pre-1 still has to be true. So that's why I want you to indicate pre-1 here. Even though we already know what pre-1 is, I still want you to write it down like this. And then what else has to be true? We are about to execute line 2. X is greater than y has to be true. Very good, because that is the condition that has to be true to get to the then portion of a conditional statement. And we are just about to begin the execution of the then branch of a conditional statement. So this is what I expect, as the first step. I know this is a lot of writing when you're handwriting this. I still want to do it like this because that's where the logic leads. Okay, so we expand what is pre-1. That's it. Okay, there's no need to do any further simplifications. In other words, even though we know that, that also means x is greater than k, well, you don't have to do anything like that. We also know that j is greater than y. Well, you don't need to do anything like that. Okay, so we can just leave it the way it is. All right, so we'll deal with, go ahead.
I was just going to ask, on the test, do you want us to do both pre-1 and x is less than y, and then x
Yes.
equals both?
Yes, because the first line shows the structure of the code, because that's the result just because of the structure of the code. The second line has to do with, in this particular case, what do we know about pre-1?
Okay.
So I need both lines. They serve, they indicate different things to me. I personally like to work on line 2 and line 4 together because structurally speaking, they are very similar. So right before we execute line 4, we know pre-1 still has to be true because we haven't done anything to the variables yet. But at the same time, we know it is not the case that x is greater than y, because otherwise we wouldn't be in the else branch of a conditional statement. So now we just expand everything just the same way as before. And if you want to simplify, that's okay. If you want to say x is less than or equal to y, but it's not necessary. Now we work on post 2. So what is post 2? Now post 2 is a little bit different compared to pre-2 and pre-4 because post 2 requires you to analyze the right-hand side of the assignment. Okay, so you need to go through those steps. So step 1 is to take a look at the right-hand side of line 2. Okay, and you say the f of y, because the variable inside the parentheses has to be the same as the one to the left-hand side of the assignment. Okay, so f of y equals to x. Does it have an inverse?
No.
It has no inverse because of which obvious reason?
It doesn't have y in the...
Exactly. The definition of the function does not involve the variable itself. So it cannot possibly be reversible if the variable itself is not in the definition of the function. Okay. So because of that, you can conclude and say this one has no inverse. And then because of that, we use the forget rule. Okay? So these two lines are important. I need to see these two lines to give you full credit because I need to know that you understand the reason why you're choosing the forget rule is because the right-hand side of an assignment statement is not reversible with respect to the left-hand side. Okay? So there are two things here. One is you identify there's no inverse function. Two, you identify that because of having no inverse function, you have to use the forget rule. So those are important things. Okay, now we move on to a slightly more mechanical aspect of this. The post-condition of line 2 is the application of the forget on the precondition of line 2. What are we forgetting? Because there are two variables mentioned on line 2. So the facts about which variable are we forgetting? Y, okay, because y is the one being changed. So we forget everything that we knew about y. Outside of the forget operation, what do we need to say? Y and x are the same. Can I do this? Would that work? This may be the 5th time I mentioned this, but doesn't hurt to ask again. Is that correct? Y gets x as a condition.
Wouldn't it be y equals x?
Yeah, exactly, because y gets x is not a comparison. It doesn't tell you something is true or false. Okay? It says, we are changing y, so it becomes x. So it's not answering a question. It doesn't give you true or false. In this case, you have to use comparison to indicate whether they are the same or not. Okay? So remember this, okay? This may be the 5th time I mentioned this, but because every year people, continue to use the assignment operation, so I have to kind of make sure that we get this done. Okay, the next line is just expanding what is pre-2, which is x equals j, and y equals k, and x is greater than y. And we're forgetting y in that big mess. Okay. And then we apply the actual forget operation. This doesn't mention anything about y, so we get to keep it. Okay, so we say x equals j, we can keep. The other two we have to forget because y equals to k mentions y, x is greater than y also mentions y, so we're going to get rid of those two. So this is the leftover. This is the only leftover piece from the forget operation. But after the forget operation, we still establish a certain fact, which is y and x are now exactly the same. Once again, even though in class I mentioned that it really it's helpful to us to make additional equalities, like in this case, because I know y and x are exactly the same, I also know y and j would be the same. Even though I mentioned that in class, in the test, there's no need to do that, okay? In the test, it's all mechanical. Whatever the result of the forget operation is, just keep it that way, okay? All right. So that's post 2. What about post 4? Post 4 is quite similar to post 2 because when you look at, it's different. On line, the first step of the analysis is f of x is x plus 1 because the function is just whatever is on the right hand side with respect to the variable on the left hand side. Is that reversible?
Yes.
It is reversible. So when it is reversible, you have to say it has an inverse of f prime. No, I can only use f prime because I can't really do the superscript -1. But on a piece of paper you can do that, so I would prefer to see a superscript of -1 to mean the inverse function. But if you use a prime, I would understand it too. So that's just x minus 1 is the inverse function. But because of that, we have to use the substitution rule. No need to spell out substitution, that's a long word. All right, so now we apply the substitution rule on the precondition of line 4. We replace all occurrences of x with the inverse function of f applied to x. I need to see this line here because this is the structure of how we apply substitution. The next line is time consuming when you're writing it because you're basically just copying and pasting what we know about pre-4, which is x equals j and y equals k and x is less than or equal to y. Then we replace all occurrences of x with f prime of x, but f prime is just x minus 1, so this is just x minus 1. I put extra parentheses around it just so that we don't have to deal with the priority of operators. The next line is really just applying it. So every time we see x, we replace it with x minus 1. So x minus 1 equals j for the first term because we have this x here that is replaced by x minus 1. The second term has nothing about x, so we just keep it the way it is. The last one, once again, has an x. We replace that x with x minus 1. Then it becomes x minus 1 is less than or equal to y. Just like that. Once again, there's no need to manipulate using algebra So even though we know x minus 1 equals j, it's the same thing as saying x equals to j plus 1. There's no need to do that, okay? So I would just I'm just expecting mechanical manipulation, okay? No algebra is required. Is that okay? All right. So now that we have post 2, post 4, we need to work on post 5, which is the last item here. Post 5, as the answer, I need you guys to mention post 2 or post 4, because that is because of the structure of the code. So you need to explain to me why, well, okay, you don't have to spell it out, but this line is required. Because this line is due to the structure of the code, it is going to be true for all conditional statements. By the time you merge the two branches, then the post condition of both can be true. Okay. Then it's just a matter of expanding, okay? But when you expand, you have to be careful. I know you cannot do it on a piece of paper, okay? But that's basically what you kind of have to do, is to make sure that you group the conjunction into one, and then group the other conjunction into the other one. So without an editor, matching the parentheses can be a little bit more difficult, but you still have to do it just to make sure that you group the items correctly. Are there any questions about this answer, number 2, for question 2?
Well, we have to split it on multiple lines.
Huh?
Well, that's
Oh, you can
huge to
split,
write out.
yeah.
Yeah, I was gonna say.
Yeah, if you want to split it, that's fine. We can just split it like using the or.
Okay.
Or if you really want it to stand out, you can use the or in here.
All right.
Yep, there you go.
Just making sure.
The question asked for explanation. Would you consider what you've written there enough explanation?
Yeah, it's concise enough. Yep. This is the most concise version. If you want to make it even longer, that's fine. All right. Any questions? Okay. All right, so if there are no questions about this, we'll move on to number 3. More code tracing. Now this time I want you to turn in a trace of the code in question number 1, except this time I want you to assume that x equals to 300 and y equals to 300 before the algorithm. Okay, so we're going back to the first one here. Okay. All right, this one's kind of trivial. Okay, so I'm going to start a new sheet for this one. Okay, so this time once again we have comments for the conditions, line number, and then we have 2 variables x and y. The precondition is 300, x and y, they both have a value of 300. So that's the given condition here. And we always start on the first line of the entire algorithm, which in this case is line 1. And on line 1, we have to indicate the result of the comparison. Is it true or false? It's false. Okay, very good. And then where do we go?
Line 5. Oh, no, it was right. Post, right?
Post. Yep.
Yeah.
We don't go to line 5 because line 5 is a part of the then branch. In the absence of the else word, there's no else branch. So when the condition is false, there's nothing to do. And since there's nothing after the conditional statement, it's post right away. And how many points were assigned to number 3, question number 3?
Same amount?
Yeah, easy 10 points. Okay, number 4 is the kind of nastier one because it wants you to reverse the execution of this code. So in this case, I want you to analyze the following code. Okay, you're given that for some constant k, the post condition of line 3 is this mess here. And I want you to step by step deduce and explain the precondition of each line. While you do not need to use the formal mathematical proof, just explain for each step how you got to the answer. Okay, so that's kind of fuzzy, but it means that you have to kind of explain something. So I'm going to work on this myself to give you an idea of what I would consider as sufficient explanation. Okay, so I'm going to start with line 3, which is already given to you. C equals 0, and y equals k plus 1, and x equals k. Okay. All right. So what I need to do is to figure out what is pre-3 based on the post condition and line 3 itself. Okay, what does line 3 do? Forget about pre and post conditions. What does line 3 do?
Assign 0 to 0.
It overwrites the value of variable z with 0. Okay? Would that give me an idea of what z was prior to this line?
I know.
Nope. Why not? It's for the same reason why we don't have inverse functions. The right-hand side does not mention the variable on the left-hand side. Okay? But you don't have to spell out that much stuff, so you can say here and say line 3 is, okay, the right-hand side of line 3 is not reversible, or you can say has no inverse. Okay? Either way is fine. So we lose track of the value of z. Okay? As a result, in pre-3, you can no longer say anything about z. But the other stuff we can still keep, okay? Because we didn't change y. Okay? Y equals k plus 1, we can keep. And x equals k, we can keep that too. Is that okay? So the explanation is just, okay, it's not reversible. There's no way I can look at the post value and figure out what is the pre-value. And if you cannot do that, you just have to lose it because it can be anything prior to this point. Okay. Then you have to say post 2 equals to pre-3. Okay. You don't have to say why. Okay. I can say that this is obvious enough, but you do have to mention that because otherwise, how do you connect the precondition of line 3 to the post condition of line 2? So you still have to indicate that. Okay. All right. So when you look at line 2, okay, it's the same deal. The right-hand side of line 2 is not reversible. Okay. However, it does have one thing. Okay, because we know that y is k plus 1. Y is currently k plus 1, but it's the result of x plus 1. So we don't know anything about, we lose track of y at this point. But we gain one thing. Well, it's already in here, so it's not going to be obvious. Okay, so we lose track of the value of y because the overwriting of y does not indicate the value of y prior to the whole thing. So we basically have to say the precondition of line 2 is just x equals k. Okay, we can't, there's nothing left except for x equals k. Is that okay? All right. Then you try to go back one more step, and then you say the post condition of line 1 is the same thing as the precondition of line 2. I don't need you to explain it because these lines are sequential because it's going to be quite redundant. Okay, now we look at line 1. Line 1 is kind of the tricky one. Yes?
Sorry, but
Go ahead.
it's possible from pre-3 to pre-2, we could replace y with x plus 1.
From
Or x plus 1, I'm sorry.
x equals 1.
X plus 1, I'm
Say that. Just say one more time.
okay, so I don't know how to put this. When we're going from pre-3 to pre-2, it's possible we could replace y in pre-3 with x plus 1.
Yes, you can reason that out and say that because y ended up with a value of k plus 1, and it's because of x plus 1, so x and k must be the same. Is that kind of the line of reasoning?
So x is the same.
Yeah, but since x equals k is already in here, so you just kind of keep that. So there's no need to explain why that is the case. It's already in the facts that they're but the reasoning does work. It's sound reasoning. Okay, so now that we are back to post 1. Now post 1 is kind of the trickier one because this is the only one where the right-hand side is reversible. So we say the right-hand side of line 1 has an inverse. Okay? You don't have to explain, I don't need formal math here, but you kind of have to reason it out. okay? Which means if I know that x is k after line 1 executes, what do we know about pre1 before x gets incremented? We know that post-increment it is k, which means pre-increment it has to be x equals k minus 1. Because in order to add 1 to become k, it has to be k minus 1 prior to adding that 1. Does that make any sense? Sorry, sort of. Okay. So that's the kind of reasoning that I want you to put into your paper. Okay. Just kind of explain step by step how you get to your conclusion. Yep.
If you're just using forget and sub, because that's kind of what we did, right?
Yes, but in the reverse way. Yep.
And that, like, could you write that out?
If you do that, though, you get full credit. Yep. But I'm trying to avoid making it formal like that. Yep. All right. Any questions about this particular version of the test? I have some additional versions. Yep. Go ahead.
So you couldn't just do x is less than k because it's not the most precise?
Correct. If you say x is less than k, it is less precise as it's less precise compared to x equals to k minus 1. Because x is less than k can be there's an infinite number of values that are less than k. But k minus 1 there's only one value, exactly one value. So if you say x is less than k, I'll give you partial credit, maybe. Because it indicates that you kind of reasoned it out, but it's not using the reverse function. It's not using the inverse function to reason it out. Is that okay?
Yeah.
All right. Any questions about this one? This is number 4, and I believe that's the last question for this particular test.
How many questions are going to be in the exam?
4 to 5, depending on the level of difficulty. I can almost tell you right away that people will not be running out of time because of writing. Okay, in other words, for someone who knows the answers, the writing part, putting stuff on paper, is not going to be the bottleneck. In most of my tests, okay, I can only tell you as statistics. Typically, some people with a 80-minute test, which is what this one is going to be, most people would walk out at about 40, 45 minutes. So the actual writing part is not going to be the bottleneck, okay? People who tend to stay an entire hour or the entire 80 minutes, typically there are two types of people like that. The first type would be me, who I was taught, okay, not to waste any time in a test. So when I'm done, I would just go over and try to spot my own mistakes as much as possible. So I would stay the entire time just to catch everything that is possible. There are also people who may not understand the concepts fully. So for those people, they need to kind of think about, okay, what does this mean? Okay, when I encounter a construct like this, what do I do next? And so on. So those are understanding issues and not really, how quickly can I write down the answer type of issues. Okay. If anyone require special accommodation because of physical disability, I cannot write that fast. The DSPS Center, the Disabled Student, what is DSPS? I think some of you know. Okay, DSPNS. American College.
I think it's just DSPS.
Yeah, the end is usually missing. There we go. Okay, this is Disabled Student Programs and Services, and this and sometimes is there and sometimes it's not. They use the ampersand instead. So for people who think that you might need extra time or extra special accommodation, the DSPS Center will evaluate and give you give you accommodation accordingly. But I cannot give you accommodation unless I have that piece of paper. Okay, so just a resource that people should look into. This is also in the syllabus, okay? In case you forget, in the syllabus, one of the items that I went through is accommodation. All right. Are we ready to move on to the next practice test?
Yes.
Okay, let's move on.
My real question is, can
Yep.
you read my handwriting?
Yeah, you have to write legibly.
Will PSPS make an accommodation for illegible writing?
I guess in that case, I'll be the one using the service, right? Now, just try to write in a legible fashion, because if I cannot read it, I cannot give you points. So
Just remember to bring a pencil instead of pen.
pencils would be good, okay? Because you can erase. And but that's only assuming you have good erasers. There are erasers where it just destroys the paper. That's one way to erase.
I get 2 copies of the test.
Okay, I cannot remember where I put the file. Okay, it's called examine.tar. Okay, let's see. Oh, it is here. If you want to open this file in Windows, the best software to use is 7-zip. So 7-zip can open up these files. If you're in Linux, obviously, it's easy to do. These are all PDFs, and you just need to look at these PDF files. There are a few versions of the same question in that year. Okay, sometimes I do it and sometimes I don't. And this is one of those versions. They're pretty much the same question, except the answer would be different because the initial some of these numbers are different. Okay, so here is the. I want to move this one. And I guess this is the title bar. There we go. I just want to move it aside so I can have some room to write down the answer, and then we use the spreadsheet. Okay, to work on this one. Okay, so this is one of the trace questions. It's a little bit different from the other one. This one has no initial condition, because the first thing we do is we overwrite the initial value of x. So there's no need for me to give you an initial value in this case. And you can also see that in this case, we have a conditional statement inside a loop instead of the other case, which is a loop inside a conditional statement. But nonetheless, okay, it's about the same in terms of how you figure this out. So we have comments, line number, and this time we only have one variable. And then what we want to do is to specify that in the precondition, we don't know anything about x. Then we start with line 1. Line 1 is just x gets 6, so x becomes the value of 6. Line 2, x is greater than 1 is true because 6 is greater than 1. Then we move on to line 3, which is the beginning of a conditional statement. X equals 5 is false because x is 6 at this point. Then we move on to where? I'm done with the only thing in the then branch of a conditional statement. So where do we go next?
6.
Line 6. Line 6 is after the conditional statement. So we go to line 6 at this point. X becomes 6 minus 1. X becomes 5. And then where do we go next? We go to line 2. Very good, because this is a pre-checking loop. We're at the very end of the body of a pre-checking loop. So we go back to the beginning to re-evaluate the condition. X is greater than 1 is still true because it is now 5. Then we go to line 3 again. X equals 5 is true. Very good. Then where do we go? With the line 4, x becomes 3. And then we go to line 6 again because we are done with the then branch. And x becomes 2. So this part is kind of tricky because we are changing x twice in this iteration. The first time because of the conditional statement, The second time because of the decrement that is outside of the conditional statement. Remember, the conditional statement and x gets x minus 1 are both inside the body of the pre-checking loop. So you got to remember to do those both. Then we go back to line 2. X is greater than 1 is true one last time. Go to line 3. X equals 5 is false. Then we go to line 6. X gets x minus 1. It is now down to 1. Go back to line 2. X is greater than 1 is now false. And we are all done. Go to post. Okay? So remember, when you exit the loop, you have to exit because of a reason. And that's why the only way to get out of a pre-checking loop is coming from the first line of the pre-checking loop. Because otherwise, there's no reason to get out of the loop. Are there any questions about this case? Yes? No? It's all good? Okay, all right. So we're going to move on to the next one. So let me go back to looking at line here. And this time we'll take a look at the second question. All right, so this is the second question. This one is kind of the same thing as the other one. You know, I give you, this is why I don't like PDF. Maybe 125%. Yep. Okay, so this one gives you a post condition, just like the other one. And this time you have two things to do. The first one is to figure out what is the precondition of line 26. And then using pre-26, go forward again. And this time you have to explain why you use the forget or the substitution rule. Go forward again and explain how you get to the same condition of post 29. So this time you have to go back first and then go forward again. Is that okay? Does everybody understand what the question is asking? Not so much the answer to the question, but what it is asking you to do. It's both ways. Starting with the post condition, work your way back until you get to pre-26. Once you have pre-26, go forward, okay? Using the same reasonings that we have been using in this class, and see whether you end up with the same result when you get to line 29. Okay, so we'll go ahead and work on this. All right, so I'm going to use my word processor.
I was gonna say, can you zoom in a little bit? Can't quite read that.
Oh,
Yeah.
okay. So it helps if I just repeat it here. So I'm gonna copy this and I just put it here. There we go. Is that better? Okay. All right. So that's post 29. Post 29 says, you know, we know the values. In this case, you know, they're all concrete values too. In other words, we know exactly that x, y, and z have these specific values. Looking at line 29, you know, what do you know about line 29? The right-hand side does not mention anything about the left-hand side.
Yeah.
So line 29, or the right-hand side of line 29 is not reversible. We lose track of x, okay? So that means the precondition of line 29, we can keep everything except for what we know about x, or what depends on x. X equals 2, we lose track of that because we have no idea of the value of x prior to this. But z equals 9 is not affected, y equals 4 is also not affected. So we get to keep those two. Post 28 is pre-29 because those two lines are next to each other. So now that we know that z equals 9 and y equals 4 as a post condition of line 29, excuse me, line 28, what do we know about the variables prior to line 28? Well, first of all, when you look at line 28, is it reversible? The right-hand side, is it reversible with respect to the left-hand side?
Yes.
It is. Okay, very good. So we write it down. The right-hand side of line 28 is reversible, which is the situation that we like, because this way we can keep just about everything that we already have. Okay? So you say the precondition of line 29 is going to be what? The first one is we know that y equals to 4 is still true because it doesn't change y. What about z? Okay, how do we reverse that operation? The operation is adding 4, right? Because y has a value of 4. So
Okay.
to reverse it, we subtract 4. In other words, if we know, because y equals to 4, that's one of the things that we already know. So if you know that after adding 4 to z, z ends up with a value of 9, what would be the value of z prior to adding 4 to it? It's 5, exactly. So just like that. And then we say the postcondition of line 27 is the precondition of line 28. And you look at line 27, is that reversible?
No.
Nope, it's not reversible. So then you have to say the right-hand side of line 27 is not reversible. Lose track of y. Okay, but at this point, okay, you can. Okay, I'll let you guys think about this for a little bit. Okay, so what do I do here? Do I lose track of y, and just keep z, or is there something I can say about x as a result?
There's something you can say about x.
There is something we can say about x because
2x equals 4.
because 2x equals 4, which means x equals 2. Okay, so that's the kind of thing that we are looking for here. Okay, x equals 2 and z equals 5. We lose track of y. That's okay because we overrode y with something that does not involve y itself. But because y ended up with a value of 4 after line 27, and the right-hand side is x plus x, we can now deduce that x has a value of 2. Is that okay? Is that okay with everyone in this class?
Mhm.
Yep.
I'm sorry, can I ask a question on pre-28, where y is equal to 4? How did we get z equal to 5 again?
Because z became 9 after line 28, right? We
So
already
y was
established
4 on
that.
27, y was 4, right?
Mm-hmm.
And then 28, 4 plus.
Okay, so we know that right before post 28 is the same as pre 29, so we know that the post condition of line 28 is z has a value of 9. Is that okay?
Yes.
Okay, so we know that after we add the value of y to the previous value of z, z has now a value of 9. So can we know the value of z before we add 4 to it?
Yes.
And that's basically the result here.
Okay. Yes.
Okay. All right. But this one is a trickier one, okay? Because we would normally just lose track of the value of y, but because y ended up with a value of 4 because of x plus x equals 4, so we can work out that x has a value of 2. Okay? All right, so this is the last step. Well, second last. Okay, post condition of line 26 is the same as the precondition of line 27. We already know that one. And then the right-hand side of line 26 is also reversible. Okay? And because it is reversible, what can we say about pre-26? After we add 2 to x, x becomes 2. So what would be the value of x before we add 2 to it?
0.
Yep, x has a value of 0. And since we didn't change the value of z, z would still have a value of 5. Is that okay? There's a little bit of algebra in here, okay? You have to kind of reason it out a little bit. Yep, go ahead.
Why does z become 5 instead of 13?
Because it ended up with a value of 9 after we add 4 to it. So what value plus 4 has a value of 9? Yep. Because if you want to use substitution, you do not use the inverse function. You have to use the function itself because we are walking backwards. All right, so now we have pre-26, but the question says, you have to go forward again. Okay, using this as a starting point, go forward again and see if we can end up with the same thing as what we did with line 29, the postcondition of line 29. So now you have to go forward. When we go forward, we say, okay, step 1, the right-hand side of line 26, f of x equals to x plus 2 has an inverse of f prime of x equals x minus 2 because it is reversible. So as a result of that, we use the substitution rule, which means the postcondition of line 26 is the result of the substitution operation applied to the precondition of line 26, replacing all occurrences of x with f prime of x. And that becomes x equals to 0 and z equals 5. That's pre-26. And we are replacing x with x minus 2. So the result of this is x minus 2 equals 0 and z equals 5. Are there any questions about the first step, going from pre-26 to post-26? That's mechanical. That's the mechanical application of the rules that we have talked about. Then we say pre-27 is the same as post-26, which is already kind of mentioned earlier. So if you miss this part, it's not going to. I'm not going to knock any points off, assuming it is already mentioned before this. All right. So the next one is step 1. The right-hand side of line 27 has no inverse. So we have to use the forget rule. Use the forget rule. Okay. So that means the post condition of line 27 is the result of applying the forget rule, but we also have to indicate y equals to x plus x after that, because that's the result of the assignment. What are we forgetting? We are forgetting in the precondition of line 27, whatever mentions the left-hand side of line 27 has to be forgotten. So that would be y. And then we just expand the forget operation. So now we have x minus 2 equals to 0 and z equals 5. Okay. And you can see that none of the stuff that we knew prior mentions anything about y. We did not claim to know anything about y, so as a result, there's nothing to forget. So whatever we had before, we keep everything this time. Just like that. Now, even though we know that x is actually 2, and 2 plus 2 is 4, you can just leave it like this, okay? No need to expand it, or no need to correlate the conditions within the post condition. All right. Then we say pre-28 is post-27. And then we look at line 28. Line 28 is reversible. So step 1 says the right-hand side of line 28, f of z is z plus y, has an inverse. Has an inverse of f prime of z is z minus y. And as a result of that, we use the substitution rule. So the post condition of line 28 is the result of applying the substitution operation on the precondition of line 28, replacing all occurrences of z, which is the variable on the left-hand side, with f prime of z. And then we just expand this. I know you cannot do this with writing.
No.
Not easily.
I was going to say, how many pages is this test? It's gonna like take
This
20
one
pages
is kind of
writing.
long. Yeah, this one is a little nasty.
I was gonna say.
All right, so now we apply the actual substitution. X minus 2 doesn't get changed. This one mentions z, so we say z minus y is 5. And this one we keep the same because it doesn't mention anything about z. There we go. Okay, now we just have one more line to go. So the precondition for line 29 is the same as the postcondition of line 28. And we do the analysis. The right-hand side of line 29 has no inverse. Use the forget rule. So now we come to the conclusion that line 28, or the postcondition of line 29, is the result of applying the forget operation, and x equals 2 after the result of the forget operation. So the forget operation refers to the precondition of line 29. The next line just expands everything. Oops, forgot one thing, because we have to mention what are we forgetting about in the precondition of line 29. What are we forgetting? Anything that mentions x, okay? Anything that depends on x, we have to forget. So now, I do this because I am going to copy and paste. Stash this whole thing here. All right, so now we actually apply the forget operation. This part we have to forget because it mentions x. Z minus y equals 5, we don't have to forget because it doesn't mention anything about x. Y equals x plus x mentions x, so we have to forget it. So now we end up with just that. Okay? Which is not the same as what we started off with. Why is that? Okay, let me scroll up the window a little bit so we can see the post condition that is given in the exam and the post condition that we ended up deriving. So we ended up with this, but the post condition that we started off is a little bit better because it has more information. We know specifically the actual values of z and y, and somehow we lost track of that in this derivation. But it doesn't mean that the current derivation will lose any points because we followed every single rule to the T. But where do we lose that information?
You stop subbing in concrete values.
Yep, exactly. If we had indicated up here that y equals to, what was it again?
Well, if you adjusted x minus 2 equals 0 to x equals 2, and then substituted in the 2 for the y.
Yep, so if we substitute the 2 into x and y equals 4, then we would end up with the same result as indicated here.
Would you prefer? Which way would you prefer it?
I would just expect this because I'm not assuming people have algebra skills in this class, even though it's preferred. There's no prerequisite. I will have to add the prerequisite for algebra if that's what I'm expecting. I know, it's something that I have to take to the curriculum to change. But as it is, this is an acceptable perfect answer. Is that okay? Any questions about the steps? No questions? Okay. All right. So before I move on to the next question, let me explain, how I am going to come up with the questions. The way I come up with the questions is based on all the material that we have covered. Okay? And how do I know what is covered in the past 6 weeks or so?
Watch your own videos?
I watch my own videos, exactly. So I am going to watch my own videos in a really quick fashion. Okay, I just kind of scan through the whole thing and go like, oh, okay, I talked about this, I talked about this, I talked about this. And all the other stuff that is linked from Moodle, that's also something that you should have read already by this time. Okay, everything up to this point, not for the entire semester. So that would also be helpful. But I'm going to go through the video to spot all the things that I can use for asking questions. So how are you going to prepare for the test if that's how I'm going to come up with the questions? But not just watching, right? You want to watch and make sure that you understand all the concepts. And for certain things, it's like, wow, he just kind of mentioned this in one sentence, but it doesn't seem to refer to it again. And if I did not watch the video, I would have forgotten. What are you going to do about that? Write it down, okay? So that's how I would study for a test like this, okay? Because you have the advantage of open book and open notes, okay? You can bring anything you want as long as it is printed or handwritten. So make use of that, flexibility. Any questions about how to prepare for this test? Okay. So with that taken care of, I'm going to continue with the other questions. Yeah, this one is a little brutal, I have to say, even by my standard. Okay, this one is just tracing the code again. Okay. Okay, I will magnify it a little bit this time and move it over here so I can show the spreadsheet on the other side. Like so, okay. So comments, line number, and this time we have three variables. We got x, y, and k. And this is the precondition. So let's check out the question. The question gives you a precondition already. This really should have been pre and not 1, but we'll understand it. Okay, so we just say the precondition is x is 2, y is 100, k is 25. Okay. So now we go back to the actual code up here and trace it. So when we get to line 1, x is less than y is true. Okay. Then where do we go? We go to not line 2, because remember, we don't trace repeat, but we do trace line 3, the content inside the loop. On line 3, we add k to x. K is 25, x is 2, so x ends up with a value of 27. And I think it really helps to make these columns shorter so I can see the numbers a little better. Then we go to line 4. Line 4 says until x is greater than or equal to y, which means we have to evaluate this condition. X is greater than or equal to y is false. And where would that bring us?
3.
Go back to line 3, because the until condition has to be true, then we can get out. Otherwise, we go back and do the whole thing again. Okay, 27 plus 25 is 52, I think.
Yeah.
Then we go to line 4. X is greater than or equal to 4 is still false. Okay. Go back to line 3. We add another 25 to 52. It becomes 77. X is greater than or equal to y is false. Go back to line 3. This time it's 102. Go to line 4. X is greater than or equal to y is finally true. And then where do we go? We are done with the entire then branch of the conditional statement because we're getting out of the loop. Is there anything after the conditional statement? After the end if? There's nothing after the end if. So we're all done. Go to post. Just like that. Are there any questions about this particular trace? No? Okay. If you think this is really boring, that's good news, because it means you already know the steps, because we're just doing the same thing over and over. Okay. All right, let's go for another question. 14. So with this test, I also only have 4 questions. All right, this one is fun, okay? It's a multi-branch conditional statement, which I think we haven't really talked about, okay? So it's not going to be in your test, okay? But I still kind of want to go over this because, in certain programming languages, you can have multi-branch conditional statements. With a multi-branch conditional statements, there are 2 things to remember. 1, we always evaluate from top to bottom. 2, if you take one branch because the condition is true, then you don't take any other branches. Okay, so it's just like that. So given that is the behavior of a quote-unquote multi-branch conditional statement, let's try to answer these questions. multi-branch conditional statements is not officially available in C or C++, and that's why it is not really one of the topics that we have to go through. C++ has a very weird way of looking at conditional statements. You will find that out next semester. And it's not a pleasant surprise either. But there are programming languages with the concept of a multi-branch conditional statement. Can someone name one programming language that has an else-if construct? Okay.
Python maybe?
Python, yes, I think Python does have it.
Case script?
Perl has it. Perl has it for sure. And I don't know whether Visual Basic has it or not. That one I do
Do you
not.
count case?
Hmm?
Do you count case as a multi-branch
Can
conditional?
case indicate, can you use general conditions in case, or
Yeah.
does it have to be a
For
constant?
whatever case it is.
Okay,
Take
so then
branches.
it's the same thing, yep, then it's multi-branch. All right, so let's take a look at this one. If a case is not possible, state so and explain why. Otherwise, state a specific value for x and y so that we get z equals to 0, z equals 1, and so on, okay, as the result of executing this. So give me a concrete example to make z equal to 0 at the end of this code. How can we make that happen? Well, it's quite obvious that we have to make this true in order to make z equals to 0. So give me one case, one instance, or one example of x and y to make it happen. X has to be greater than 5, and y has to be greater than x. I can come up with countless examples. Go ahead.
X is 6 and Y is 7.
Yep, x is 6, y is 7. That will meet the requirement. Okay, that's not too hard. Okay, so I'm going to document it using my text editor. There we go, and it's already at the right place too. Okay, so z equals to 0. As an example, I can make x equal to 6, y equal to 7. That will make it work. Okay, next one up. So the next one, I'm just going to hide the ones that we have done already. So this is the next one. I want a concrete example so that z ends up with a value of 1 at the end of this code. In other words, I want this branch to execute. Now, this is the tricky part. In a multi-branch conditional statement, if you take the first branch, it's not going to take the second one.
Yeah.
So you have to figure out something where this condition is false, but this condition is true in order for z to end up with a value of 1. Okay. Z equals 1 when x equals 6, y equals 6 also. That will make it happen, right? Because when x and y are both 6, y is greater than x, it's going to be false. So that will make the condition of line 1 fail. It's going to be a false. And that would make the condition of line 3 the first one that is true. I don't even care what goes after this one, because as long as this one is true and the first one is false, I will take this branch. Okay? Okay, so that takes care of that. And let's see. Yeah, the scrolling doesn't work too well because I will scroll off the entire screen here. So I'm just going to use this here and say, okay, what about z equals 2? Is that possible? And if so, how do we make it happen? That's not too bad. Okay, so in order for this condition, in order for this branch, in order to take this branch, this condition has to be true. But the other two on line 1 and line 3, they have to be false in both cases. Okay, can we make that happen? How about this? Wouldn't that fail both conditions, the one on line 1 and the one on line 3? Okay, so then we can just say that, okay, how do we make y greater than x? Well, y equals 4. That should do it. Next one, z equals 3. Is that possible? So you look at line 7, the condition of line 7, and you say, is it possible for the condition of line 7 to be true when the conditions of line 1, 3, and 5 are all false?
No.
Think about it. It will not be possible, because if the condition of line 5 is false and the condition of line 3 is false, that means both components of the disjunction of the condition of line 7 are false. false or false is false, which means it's not possible to make the condition of line 7 true when all the previous conditions are all false. Okay, so it is an impossible branch. Okay, so we just say it is impossible because the condition, okay, if all the conditions on lines 3 and 5 are all false, the condition of line 7 is false also. Okay, so that would be a good explanation. Okay, how about z equals 4? Is that possible? Just because you have what we call a dead branch doesn't mean all the branches following are dead as well. Okay, it is entirely possible that these are still possible. Okay, so let's take a look at line 9. Okay, line 9 says, I want x greater than 4 to be true, but all the other conditions to be false. Is that possible?
C equals 5.
Yeah, just one case. So we want, in this case, we want x to be exactly 5, right? Because otherwise x is greater than 5 and it would make one of the other conditions true. But we also want to make sure that y is greater than x is false. Okay? How do we make that happen? Yep, that will do it. So this is a tricky one because there's one branch that is still live after a dead branch. So a dead branch does not mean everything after that is also dead. It simply means that one branch is impossible. Okay, let's take a look at z equals 5. Okay, is that possible? Yes? No? Okay, the first thing is, x is greater than 4 takes care of everything, with x is 5, 6, and so on. So let's work with, let's try, x being a much smaller value, like 3. But we already have one like this, okay? But in this case, y specifically has a value of 4 to be greater, right? And then the other one, we have another one like this, with y being 4, which is less than. So the question is, can we catch z equals to 5? Is that branch possible? Yes? Okay, so what do you think y should be?
3.
Y would be 3 too?
3 or 2.
Okay, so let's check whether this will work or not. The first condition is going to be false. Very good, because x itself is 3, so 3 is greater than 5 is false already. This is also false. This is also false. This is also false. This is also false, which means that we default to the else case. Good job. That's it. So are there any questions about answering a question like this? I won't give you a multi-branch conditional statement because we never really talked about multi-branch conditional statements. So the test is once again, when again? No. Next Monday. Next Monday, 1 week from today. So that would be 168 minus 1 hour and a half. Okay. Which also means if you study before Wednesday and you find one question and you say, okay, I'm not quite getting this part, bring those questions on Wednesday so we can talk about it.
Too much writing. Sure you can't type out my desk? Sure you can't type out my desk? Too much writing.
Too much writing. Well, try your other hand.
This is a computer science class. Typing should be,
I actually once had a student who complained and say, not being able to use a computer and use a keyboard make me a disabled person. And say I need special accommodation because I cannot type.
Have you looked at my handwriting?
No, I just sent that person to DSPS. If they sign up the paper, sure, you can get accommodation.